To solve a radical equation like this, we want to isolate the radical. And in this equation here, all we have to do is get rid of the 1 on the right-hand side. So we're going to we subtract 1 from both sides, so we're going to be left on the left-hand side with x minus 3 equals square root of 2x minus 3. To get rid of the radical, we square both sides. X minus 3 squared, if we expand that, we're going to get x squared minus 6x plus 9. And that's the left-hand side. On the right-hand side, the squaring of a square root just eliminates the square root, and we're going to be left with 2x minus 3. We move all the terms to the left-hand side and combine like terms. So we have negative 6 minus 2x is negative 8x. And we have 9 plus 3 is going to be 12. At this point, we have a trinomial where the numerical coefficient in front of the x squared term is a equals 1, which means that we can use the method of inspection to factor it. So we're looking for two numbers whose sum is negative 8 and product is positive 12. And those two numbers will be negative 6 and negative 2. If we add those up, we're going to get negative 8. If we multiply negative 6 and negative 2, we're going to get positive 12. So now we can factor this trinomial, and we're going to get x minus 6 times x minus 2 equals 0. And now we can see, using the zero product theorem, that the two roots are going to be x equals 6 and x equals 2. Now, anytime we are solving algebraic expressions that involve radicals, and we get rid of the radical by squaring the radical, we have to verify our roots, because we might get invalid roots. So we're going to verify. Verify solution. And what that means is that we're going to take the original expression and we're going to replace the variable x with those two roots. So I'm just going to write down the original expression first. We start by substituting in 6 for x, so we're going to have 6 minus 2 on the left-hand side. And on the right-hand side, we're going to have 2 times 6 minus 3 plus 1. The left-hand side is just 4. 2 times 6 is 12, minus 3 is 9. So we have square root of 9 plus 1. Square root of 9 is 3, so we have 4 on the left-hand side. 3 plus 1 is 4. So in this case here, the left-hand side equals the right-hand side. So this is the x equals 6 is a valid root. We have to do the same thing for x equals 2. We substitute it in. It's going to be 2 minus 2 equals square root of 2 times 2 minus 3 plus 1. 2 minus 2 is 0. 2 times 2 is 4 minus 1. Minus 3 is 1. So we have square root of 1 plus 1, which is going to be equals to 2. And here we can see that the left-hand side is not equal to the right hand side, which means that the 2 here is not a valid root and we have to reject it.